I'll be showing the automation simulation of automatic bottle packaging using Automgen software. The components used in this simulation are start-stop button, 3 proximity sensors, 3 conveyor motors, 1 water filling station, 1 bottle capping station, 1 bottle dispatching station. Then we have 3 timers, 3 counters, and 12 user memory bits. Uh, this is the ladder logic which is used for the automation process. This is the first rung, and this is the start stop. This is the start push button, that is percentage I0, and percentage I1 is the stop push button. Percentage M100 is the first power cut memory bit being used in order to control the bottle filling station component. This here. Then in the second rung transfers memory value from power control memory bit to first user memory bit and controls the conveyor motor. In the list of components, we have 3 conveyor motors, as in the solution which we had given for the problem statement. We say that we use 3 conveyor belts, and adjacent to the belts there are 3 respective stations, that is the filling station, the capping station, and the dispatching station. The power control memory and the user memory control the first motor. Percentage M102 is the feedback memory of the sensor used. 102 here. Then in rung 3, we will be controlling. It will be controlling the previous conveyor belt motion and the nozzle action, which is used to fill the bottle. Then in rung 6, the power control will be will control the sensor, and the sensor will control the counter, so that we can get the value of the number of bottles that pass through each station. We are allowed to reset the counter after the stop button has been pressed. The whole process is applicable for bottle capping and dispatching process, and the same ladder logic is used with different user memory and power control memory bits. The sensor detects the increment in the counter place. Then basic HMI is made using the IRS2D function. In this process, we have 3 processes. That is the bottle filling process, the bottle capping process, and the bottle dispatching process. So now we will run and compile the ladder logic and run the entire process and perform the simulation of the system. After we compile the ladder logic, we need to give the timer a specific timing in order to control the conveyor belt and the station components. So the first timer will be given a time of 7 seconds. This is the first timer that will be given a time limit of 7 seconds. Then we have the second timer here that is given the time limit of 5 seconds. And then finally, for the third process, the third timer is given a time limit of 3 seconds. After setting the timer, we have to start this system. After we place the bottle on the belt, which is having a depression on it, which acts as a holder to maintain the alignment of the bottle. When we trigger the proximity sensor, the timer starts and the belt stops, and bottle is filled, and after it's done, the belt will continue. For bottle capping, the bottle will come in the range of the proximity sensor and will stop the belt and start with the capping process. And this process takes 5 seconds, as we have already specified. When we finish the first 2 processes, we need to dispatch the bottles into boxes. So the bottles are taken towards the third process, that is the dispatching process. When the proximity sensor detects the filled and the capped bottles coming towards it, the arm will take the bottle from its position on the conveyor belt and put it into boxes. And thus the process continues repetitively for different bottles until we reach the desired quota, or the desired number of bottles that have to be filled, capped, and packed. In the scenario of an emergency, or default, we can use the emergency stop button to stop the entire system.